Hello, good evening, everyone. Thank you for coming back, and I hope you have a tea or coffee and have enough rest. And now is our last session, last workshop for the ABCDE event, and here we have Miss Shumin, and to continue to her sharing, and her topic is the data engineering fundamentals. So, Shumin, it's your time now. Okay.
Thank you, James.
Hmm.
Okay, so welcome back everyone to workshop 2 of the day. So again, thank you for taking time off to attend this workshop on a Sunday afternoon. Let me share my screen. Can you all see my screen?
Yes.
Okay, thank you. Okay, great. So I'll move on to our other workshop for today. So our second workshop for today basically is just some data engineering fundamentals. So just be another introduction level workshop on data engineering. So again, for those of you who are not in the first workshop, my name is Shumin. I'm from Smartcademy. So Smartcademy is a training company based in Singapore where we do online training sessions in all areas, namely data analytics, digital marketing, front end, UI, UX, etc., etc. So if you're interested, feel free to head over to our website to find out more. Okay, so also a bit about myself. My name is Shumin, and I have been in the data industry for about 4 years now. And I started off initially as a data engineer, focusing on big data. But after like 2 years, I decided I wanted to move on to do more data science work. So I'm focusing a lot more on natural language processing, looking into text analytics, text data as well. So for any of you who are interested in any of these areas, be it data engineering, big data, NLP, and you have any questions, feel free to reach out, or you can put it in the Q&A as well. So again, same as just now, I'll go through the content, and I'm unable to see the Q&A questions now, but I'll try to answer as many of the Q&A questions later on. And again, for this session, we'll have a hands-on section later on. So I'll be sharing the materials later as well. Then you can refer to them. Okay. So we'll go on into today's workshop. So we'll be looking into data engineering today, namely what is data engineering, and then we'll be talking about the ETL process, which is one of the key processes, key goals of a data engineer. And then we'll be talking about what are some of the tools that the data engineer uses. But for our hands-on session, we'll be looking at Python, and we'll be looking at a specific Python library, PETL, PETL, basically Python ETL, and see how we can use that for data engineering, for some simple data engineering. Okay, but disclaimer, of course, there are other data engineering tools, that enterprise level tools that different companies use, but due to like the different licenses, we're unable to use it for our hands-on session. So that's why we'll just be looking at Python today. Okay, and then if there's time, we'll talk about some data engineering trends as well. Okay, so let's start off. What is data engineering? So for those of you in the data industry, right, you probably, and those of you who don't know data, who may not have heard of data engineering before, but you may have heard of like data science. So one of the misconceptions that people tend to have is, oh, data science is data engineering. Okay, but there is a big difference between data science and data engineering. Okay, so data science really focuses more on the modeling, building the models based on the data, whereas the data engineer's role is really very important in cleaning the data and ensuring cleaning data, transforming the data, and really ensuring that the entire data pipeline is good so that the data science can build their models. Okay, and then there's another very big misconception that's saying, hey, data science is more interesting, more sexy, better than data engineering, but that's not necessarily so. Okay, so a lot of times, right, like you hear a lot of interesting news saying that, hey, now there's this new AI algorithm, there's this new machine learning algorithm that you can use to try and build a recommender system, or that you can use to prevent insurance fraud, all that kind of things, right? And then people are just looking at the models and saying, oh wow, this is so cool. But what they don't understand, what some of these non-technical people, what they don't see is that under all that like cool data science models, right? Actually, deep down, the data engineers are the ones working really hard to make sure that the data is usable and is suitable for the data scientists to build their models. Okay, so really the data engineers, there is no such thing as, oh, data science is more important than data engineering or whatever. Okay, so these are just some misconceptions I'd like to clear. And then there's another myth that, oh, all the data engineer does is coding every day. So they're just like coding ETL pipelines and all that, and it's really just all coding. Okay, but that's not necessarily the case. Okay, because as a data engineer, we'll be talking about this later, but it's not just all coding. Like the data engineer does not just do all coding. Okay. So basically, what is the role of a data engineer, right? So as mentioned just now, the data engineer's role is very important. It's basically to ensure that like their main aim is just to focus on the data and ensure that the data is suitable so that the end users, be it the data analyst, be it the visualization analyst, be it the data scientist, when they use the data, it is clean and suitable for their models or for their visualizations to work. Okay, so as the saying goes, right, junk in, junk out. So if your data is junk, right, if you have like inaccuracies in your data, if you have missing data, if you don't have the right data, right, whatever analysis is done downstream, be it your data science models or your data visualization, right? It's going to be junk as well if your data is junk. Okay, so the role of the data engineer is very important in the entire data industry. Okay, so so data scientist focuses on finding new insights in the data set. They're the ones that are building the models, whereas the data engineers are really more concerned with the production readiness of the data, ensuring that the data is ready, the data is suitable, clean, standardized, formatted, and all that for their end users. Okay, so that's the key difference. So there's this like kind of like data science hierarchy of needs. So you can see like at the top we have AI, deep learning, all the cool kind of models that people do. But of course, if you really look at the hierarchy of needs, like what are the key things that you need to do before you can even get to your AI, deep learning, machine learning models, right? Really at the fundamental at the bottom, right? The key things, like the rudimentary things that you need to do, right, is to ensure that you have, for example, a reliable data flow. You have the right infrastructure to store all your data. So if you're using a big data infrastructure, for example, you must make sure that you have the right tools, the capabilities to be able to store all these big data that you have. Okay, you have your ETL structures, you have your structured and unstructured data storage. So if you're storing structured data, or if you're storing unstructured data, you're storing it properly. So that, for example, if you're storing text data, right, you're going to do some sort of text analysis to analyze all your text data. Maybe you're going to do some sentiment analysis, identify whether or not the general sentiments of a certain topic you have is positive or negative, right? You need to make sure that you store this data properly in whatever storage system you have, so that maybe the data scientist at the end can use this, can take this data, cleaned data, and use it for your sentiment analysis. Okay, so really the fundamental skills that you need in any data industry, right? The fundamental role that the data engineer plays really a very fundamental role to make sure that the data is all ready and it's all clean and is good for building models or building your visualizations. Okay. So the main goal of a data engineer, right? So like when I talk about a chef, I want to say like the main goal of the chef is to make food, right? I don't say like, oh, they chop onions or whatever. So like the main goal of a data engineer really is to like build data pipelines. Like really their focus is on building the data pipeline from ingestion, from getting the data all the way to storing the data somewhere, such that other people can take it and use it. So essentially they're really just taking the data, cleaning it and putting it somewhere else where other people can use. Okay. So the key goal of the data engineer first, of course, is they need to talk to the end users, be it the data analyst, the data scientist, the visualization analyst, whoever who is going to be using the data, using that end goal data, right? They need to understand the data requirements. What is the data that you require? Are you expecting the data to come in streaming? Are you expecting it to be updated on a batch basis? What are the columns? What are the key values that you need for specific columns? Is it supposed to be integer, or is it supposed to be a date time? Is it supposed to be a time delta? What are the data that you need. So it's really not just all about coding. I mean, of course, you have ETL development, which is the next thing we'll be talking about. But there are some aspects where you need to talk to your business, your users, your end users, okay, and understand what are the data requirements, okay. And then, of course, you have your ETL development, where you are, which we'll be talking about. Okay, so ETL development, what is it? So for those of you who may not have heard of ETL development, this is like a key process, a key part of a data engineer's role. Okay, so what does it stand for? So ETL basically stands for extract, transform, load, ETL. And basically what it does, right, is this entire process is where you actually get data. So you extract your data and then you transform your data to whatever, to however you want it to be, your ideal, your optimal state. And then after you load it, you store it somewhere so that other people can take it on and use it. Okay, so that is ETL. So why do we need ETL tools, right? So firstly, when you have all these different tools, it actually improves the time efficiency. Meaning, right, when you have all these tools, when you have all your Python scripts ready, where you've done the ETL on your data, right, you can actually automate your ETL process rather than like someone clicking or someone doing the extract process, someone else doing the transformation process, someone doing the loading process, etc. When you have it in an automated way, right, it's a lot more efficient, okay, and it's a lot faster. By automating it, you also reduce any chances for error, okay, along the entire process, meaning there's no instance where you potentially load the data before it's transformed, okay. You know that it has to follow the step extract, transform, load, okay, so that it reduces the chances for error. Okay, and when you use tools, it also manages the computational resources. So jobs can run faster and much more efficiently. You're able to identify, you're able to do some sort of scheduling. So for example, because whenever you're looking at, for example, running jobs, right, and your data, you have to be conscious of how big your data is, and you have the right resources. You have enough RAM, you have enough compute to run your script on this data, okay. And finally, you also want to manage all of the ETL transformation steps. So when you have all these tools, when you have already written your entire script properly, right, you already know that first I want to load the data, and then once I load the data, the first thing I want to do maybe is remove any null values before doing anything else, right? When you have it all scripted out already, you will know that you always remove null value first rather than do other things before removing null values. Because the order of the transformation sometimes will play a part in how your data comes out at the end. Okay, so that's why we need some ETL tools. So let's go deep into the ETL process, extract, transform, load. So let's start with extract first. So extract, right, really what it entails is getting the data, downloading the data, and bringing it on board. So data can come from like a single source, or it can come from multiple sources. So it depends on your entire organization setup, or it depends on your own setup lah. So it can come from one source. You may just be drawing data from one source, but that's highly unlikely. So usually, whenever you're doing any ETL, right, you're probably getting data from multiple sources, okay? And some of the sources can be things like ERP, your enterprise resource planning systems, your CRM, customer relationship management, okay, where you have all your customer data, typically for any more like banking kind of industry, or more like retail where you have more customer kind of data, or Internet of Things sensors. So if you recall in the previous workshop, we talked about Internet of Things, briefly talked about Internet of Things, whereby you have like different sensors collecting data for you. Okay, so it can be in a industrial plants, right, in a factory, right. You can have, for example, the temperature of all your your machines. You can have how many machines are working, how many machines are not working, sensors to get all these kind of data. So you can get data from that is also another option, another source of data that you can get from. Okay. So it's a good practice to audit your data sources. What does that mean, right? So you want to make sure that whenever you get your data, right, these are all, your data is of a good quality and you can utilize it for a specific purpose, okay? But of course, typically in a large organization, right, sometimes you have another role called a data strategist, and the data strategist is the one that is looking out for all these new data sources. So as a data engineer, you are kind of given the source. So the data strategist will come and tell you, hey, we're getting data from this ABC. These are the sources we're getting our data from. Then the data engineer will take all these sources and put it into your ETL process. Okay. Yeah, but that's typically for organizations with a data strategist. If there is no such thing, sometimes the data engineer may have to take on that role as well, and then they have to go and source for their data. Okay, but whenever you're sourcing for your own data, you need to make sure that your data sources are accurate and that they have like and then you ensure that the data is of good quality and that you can use it for whatever purpose you want. Okay. So there are typically two different ways that we get our data. So I mean, we can say that we get our data we can get our data from IoT, Internet of Things devices, sensors, right? Or we can get our data from like the ERP systems, or we can get our data from CRM systems, right? But how do we get that data? So does someone like come and pass us a thumb drive with the CSV or what? Okay, so typically there are two ways that we actually do it. The first way is API. API basically stands for Application Programming Interface, whereby it's just a software intermediary that allows two different applications to talk to one another. Okay, so if you're a bit lost, don't worry. Later on in the hands-on, I'll be showing you an example of an API and how we can actually use an API to get data. Okay. Besides an API, another way that we typically also get data is something called FTP, File Transfer Protocol. Okay, so File Transfer Protocol is another method where you transfer files between like a server and a client. So you need to set up a connection between you and your other server, and then it would like automatically send you files through that connection. Okay, so there are two different ways. It's either FTP, File Transfer Protocol. It will just send you files, or sometimes bigger organizations, enterprises, they prefer to use SFTP, Secure File Transfer Protocol, because it's secure as the name suggests, whereby you need to have a username and a password, or you need to have some sort of encryption keys set up before you actually send the file over. So this is to prevent other random hackers or random people from sending you files. And sometimes it could be a virus, it could be a bug, or sometimes if you get too many files, it will also just take up unnecessary storage space in your database. Okay, so FTP, File Transfer Protocol, or SFTP, Secure File Transfer Protocol. So later on in the hands-on section as well, there will be like a short part on FTP, SFTP, but that won't be our main focus for today. We'll be focusing more on APIs because typically nowadays we are moving towards getting our data from APIs. Although there are instances where people, organizations do choose to use FTPs as well. Okay. So when your data comes in, be it API or FTP, right? SFTP, FTP, typically it can come in different formats. So if it's an API, you would usually expect a JSON or XML format. Okay. But if it's an FTP, File Transfer Protocol, you can expect CSV format, Excel format. It could even be sometimes a PDF or Word document. Basically, it's sending a file over. And you can also get data from other places, for example, a SQL database, right? Sometimes you can just connect to a database and query your data and get it into your processing engine so that you can process the data and maybe store it somewhere else later. Okay, so really data can come in many different formats. So there are also three different ways of extracting the data. Because whenever especially if you're using a production system, right, and you're getting data into your production system, you want to make sure that whatever extraction of data you do doesn't affect your production server, because there'll probably be other applications running. And let's say if, for example, you do a full extraction, right? A full extraction means you take all the data in one shot. If that sudden spike in data come into your database, it could potentially cause a problem where suddenly there's so much data, right, that your entire network speed goes down and affects all your other production processes. So that's why sometimes instead of doing a full extraction, meaning taking all your data in one shot, another thing you can do is an update notification or incremental extraction. Update notification just means that when your data is updated, when your data comes in, you will get a notification to say, hey, this data has been changed, this data has been updated. Another way is incremental extraction, whereby it just incrementally comes in batches. And you can define how you want it to come. You can come in, for example, you can take January data first, February data first, etc. Or it could also be like you could split it based on your customer segments. Maybe you take all your customers stay in Asia first, then after that all the customers in Europe or whatever. So it can come in many different ways. You can define that based on your own use case. Okay, but these are typically the three different ways you can extract data. So, what are some possible challenges that you can face during this extraction process, right? So, some things you need to take note of whenever you do your extraction process is that there could potentially be change in data formats over time. So, for example, right, for example, you would expect maybe like HTTP error codes. Okay, like you would expect if you know like HTTP error codes, right? Typically they'll be like 404, error 404, error 501, error 502. They're all like numbers, integer format, right? But for whatever reason, sometimes suddenly you may get an error code 404A or 404B because on the backend side, your application developer suddenly created a new error code 404A for a specific purpose. But when you're collecting error codes, you've been always collecting it as integer, but suddenly 404A. So if you have any alphanumeric, it'll typically come in as a string rather than an integer or float, right? And that could change your entire storage. It could, it could. So if you store it in your database and later on the data scientist comes and use it and they typically expect integer but suddenly there's a string, that could mess with their entire data modeling script. Okay, so these kind of changes in data formats, right, you need to ensure that your script kind of like accounts for that. So there are many different ways. You can either do a try except. So if the format coming in is not according to what you want. For example, if it's not an integer, what should I do? Should I email the data engineer, or should I send a message, or should I just throw the data away, or should I store it in a different database, or should I just store all the data? What should I do? So you should have some sort of procedure in place to take care of all these kind of edge cases. And of course, it's good to have talks with like your data source, the people who are sending you the data, if it's possible, if they are within your same organization or they are within your same project group, you're able to talk to them, then you can have conversations with them to ensure that the data is always coming in of the same format. And if there's any changes, you should be aware. If you're unable to do so, then of course you will need to put it in your code level. Okay. So besides change in data formats, other things, I'll just talk about maybe three more. Okay, the rest you can go back and read. Will be like things like increase in data velocity and volume. So suddenly there could be a huge influx of data again. So back to the example I raised earlier, for example, if there's like a 7/7 sale in the e-commerce industry, and you know that when there are all these kind of like 7/7 sales, and suddenly a lot of people will start buying things because they'll expect like huge sales and all that, and there'll be a huge spike in your transactions again. So because of that, you need to account for such things. So if you know that, oh, there's going to be a huge sale and I'm going to be expecting a lot more transactions, can my database take that increase in velocity and volume in data coming in, or is it gonna break down? And if it breaks down, that's going to be horrible, right? Because we're not going to be storing all this data, so you need to have a backup plan or something. Okay. So yeah, increase in data velocity and volume. Again, if you recall from the previous workshop, we also mentioned this can be accounted for if you know it's going to be something like big data. You can have like a cluster. So if a single node goes down, it's fine. You can still have other nodes that will be available. Okay. Another possible problem is like rapid changes on data source credentials. So this is typically more crucial for SFTP, Secure File Transfer Protocol, because typically when you do a SFTP, you need to put in your credentials, your username and your password, right? Or you need to exchange encryption keys. So if there are going to be changes in that, you also need to take note of how to account for that. So are you going to someone probably has to go down and key in, update the user and password config file or something. Even with APIs, okay, so sometimes if your API key changes for whatever reason, you also need to update that in your script. Okay. So there are many different challenges. These are just some of the challenges that you can potentially face during the extraction process. Okay, and it will be good if you are aware of it so that you can account for it before it happens, and then that will cause a problem downstream. Or of course, sorry. with experience, right, you'll be able to, I mean, you would sooner or later come across these kind of problems, and then you would know how to what's the best way to account for it. Okay, and of course, there are custom applications that may be required. So depending on your ETL tool that you use. So if you are using a tool, a specific enterprise tool, sometimes you are like kind of like restricted based on the features that that tool has. So that's why if you use like your own Python script, right, you're able to really customize. If you have to code, if you can go down to code level and change your code, right, you're able to customize your code. You're able to change things. You have a lot more freedom in your ETL process. Okay. So yeah. So that was for extraction. So next we go on to transformation T. So what is transformation, right? So once you've extracted your data from a single or multiple sources, and then you've gotten your data, the next thing that you need to do is transform your data. So you need to get this data that you have ready to match whatever your data scientist told you that they wanted, or whatever the visualization analyst told you how they wanted the data. You need to get it ready, get it in that format. Okay. So again, for transformation, right, there are many different techniques that you can use. The very basic ones that we typically have is like cleaning, the basic data cleaning. So any inconsistencies, any inaccuracies in your data. So for example, the integer and string format, right? If when you extract it out, you have integer and string, how do you account for that? Should you remove all the string format, or should you try and convert the string to an integer? Or what should you do? Okay, so typically you want to clean your data to make sure it's all consistent. Yeah, and then the next thing that you want to do is standardize your data. So it's to make sure that your data is of all the same type, because especially if you're taking data from multiple sources, right? For example, if I have Asia data and maybe Europe data, right, I want to make sure that the date time is the same. It's year, day, month. Because sometimes from one source it could be year, day, month. From another source it could be year, month, day, right? Year, month, day rather than year, day, month. So you have to standardize all of your data to make sure that they follow the same format, so that when any analysis is done, it's correct. Okay. Then of course we have duplicates. So sometimes there may be occasions where you have duplicated data inside the data that comes in. It could be for whatever reason. Sometimes it could be if you do a FTP, file transfer protocol. Sometimes the people at the source actually accidentally send over the file 2 times, and you get an entire duplicate of data. Or sometimes it could just also be like transaction level. Maybe sometimes the person accidentally keyed in the transaction twice. Okay, so for whatever reasons, there may be duplicates in your data, and you need to run a deduplication of your data to make sure you remove any duplicates. Of course, this is based on your use case. So sometimes if you need to capture all these kind of duplicated data. For example, if someone actually wrongly keyed in the transaction twice, and you need to find out these kind of anomalies in your data, right? Then you can probably skip this step. So it's always dependent on your use case. Okay. Next will be augmenting. So sometimes you can also augment your data, meaning besides pulling data from your existing sources, right? Sometimes there are instances where you actually buy data, where you can use it to augment your current data. So for example, right, postal code. You may have the address and you have the postal code of your customers, for example. You can augment your data based on the postal code, right? You may be able to get the district that the person lives in. Or maybe based on IP address, you can try and identify which country this IP address is from. So all this, right, is additional data that you can buy and then augment your existing data. Okay, so you can get more information on whatever existing information you have. Okay, so moving on. So those were like the more basic kind of like transformation techniques. There are also more advanced transformation techniques that we have. Typically, it can be like splitting a single field into multiple fields. For example, your date time field, right? You have year, month, date, right? Maybe you can split it to year and month and date separately as 3 separate columns. Or for example, in an address, you can have the address and you can have the postal code, right? Sometimes you may want to split that up, or whatever other examples you may have. Sometimes you may want to split a single column into multiple columns. Okay. Then of course another thing that you can do is you can do mapping. So meaning you can join multiple data sources as well, right? So if you have a identifier column, an ID column that you're able to join different data on, you can also do that kind of mapping. And of course, you can do aggregation of your data, calculated and derived values. values. So for example, based on all the different transactions that your customers have done, right? What is for this specific customer? What is the total amount that they have spent on your products, for example? Okay, what is the total revenue from from this customer? What's the total profit from this customer? What's the total loss from this customer? So all these aggregated values you can also get through transformations. Okay. So so those are like just some samples of transformation techniques. Of course, we are not limited to all those. Okay. So for transformation, right, what are some potential problems that you also need to take note of? So typically, if and we're splitting this into two different parts: single source and multiple sources. So if you're just looking at a single source of data, right, some possible data problems would basically be like spelling mistakes. If you're looking at unstructured text data, um, redundancy or duplicates within your data. Sometimes your data may be outside the domain range. For example, you may have maybe, for example, you're just interested in primary and secondary students, okay, but suddenly you have data that's coming in, and these students are like university level, so they're outside your interest, your domain interest, so you can filter those out. Okay. Sometimes you have data entry errors, right? So sometimes, like, if a person is supposed to be a female, you put FEMALE versus someone else who just puts M. So you want to standardize all these values. Okay. And of course, sometimes you may have contradictory values. For example, one data source tells you this IP address is coming from maybe Singapore, and then another data source that you bought is telling you that this IP address is coming from maybe, I don't know, Taiwan. So how are you going to resolve that conflict? You just remove both, or what do you do? Okay. So that's for single sources of data. So sometimes if you have multiple sources, when you're dealing with multiple sources, other sort of problems.
Slide need to reshare again.
Oh no, it's just happening.
Yeah.
Okay, I'll share my slides again.
Yep. I hope you guys catch the session just now. All right. So any questions, please feel free to drop in the Q&A tab. All right. Okay, I can see now.
Okay, great. I'll continue from here. Okay, so yeah, I'll just continue from here. So we were talking about single source and multi-source data, right? So some of the potential problems that you may have from multi-source data basically include sometimes there may be naming conflicts. Okay, so you may use different names for the same column. So that kind of thing, you just need to change or to standardize your column names. Okay, structural conflicts. So this is talking about, for example, your date time. Is it supposed to be year month day or month year day or whatever? What is the correct format you want to follow? Like timings, for example, if your data is supposed to come in inconsistent data. So basically, if there's inconsistent data in your data source, so maybe one of it is saying that this data source is similar to what I mentioned just now, basically here, where there's contradictory values, where you're supposed, for example, if one data source is saying this IP address is Singapore versus another data source saying this IP address is from Taiwan. So how do you resolve that? Okay. So typically, there are two main approaches that we like to use for data transformation. So the very kind of like traditional way is basically using ETL. So it's a multi-stage data transformation. Basically, it's an ETL transformation where you extract your data, and this extracted data is put into some staging platform. So it's called your extracted data is now a staging platform, and then after you do all your transformation. Okay, so that's your ETL, extract, transform, load process. Another way, so that's your multi-stage data transformation. Another way that you can do data transformation is called in-warehouse data transformation. So it's a bit different from your ETL process. In fact, it follows an ELT process, extract, load, transform. So the difference is that, right, once you extract your data, you don't transform it immediately, you store it, and then the next user comes and loads the data, and then the transformation occurs. So when do you use which, right? So typically ETL, it has always been the traditional ETL process. So it was only with actually big data that with big data, right, that there was a shift towards this ELT process, extract, load, transform, whereby you actually have something called a data warehouse, and it's only in the data warehouse where the transformation will actually occur. So if you recall back to our previous workshop where we talked about Hadoop and Spark, right? So ELT, you can kind of think of it as you extract the data into Hadoop, okay, and then you store all your data there, and then you only load it into your MapReduce or your Spark processing engine, and then you transform your data there in your Spark or MapReduce processing engine. So that follows a more ELT kind of approach. Okay, so typically we always use ETL, but with the shift towards big data, that's why we've slowly been moving towards ELT as well. Okay, so that's just to let you know. So finally, we move on to load, right? So load is basically loading your data into the end target cell. So once you've gotten all your data, extracted your data, you transform it, you will then load it into a final data source where your end users will actually take this data and use it for whatever purpose. Okay. So there are different ways to load your data. So typically, you can load it into a flat file, a delimited flat file, basically like a CSV file or text file, and store it somewhere. Of course, another way to do it is to store it in a data warehouse. Okay, so typically for any analytics purposes, right, data scientists like to take the data from a data warehouse. Okay, so it depends on the requirements, whether you want to store it in a flat file, a data warehouse, a database. Once you transform your data, where do you want to store it? So it depends on your requirements. Okay. So some considerations, right, that you want to take note of whenever you want to make sure that you have any effective loading, right, is essentially that if you have any additional indexes, maybe you can remove that from your final data, because it's not really necessary, especially if it's not necessarily for your end users. They may not necessarily need all these indexes to do their analysis. So it's typically more important for you as a data engineer to have, and it may not be necessary for your end users. And if that's the case, you can actually remove all those. Okay. Another thing you can do is to manage your partitions of your data, how you partition your data. So one way that the most recommended strategy actually is to just do it by date interval. So you can store all your 2020 data, and then your 2021, and then your 2022. So you can partition by year, or you can partition it by month, by quarter, etc. And of course, some other organizations may choose to, instead of do it by year, right, they can do it by their customers. So whether or not this is a loyal customer, whether or not these are their premium customers or their loyal customers, or just their ordinary customers. So that's another way that you can load your data. So again, it's really dependent on how your end user, your data scientist, data analyst, or data visualization people want to make use of the data. And then based on that, that's how you can actually load your data. Okay. Yeah, and of course, if you're doing incremental loading, so again, if you recall how we extract data, right, there are three different ways: a full extraction, or incremental extraction, or update notification. So same thing, right? If you're going to be loading your data, storing it, saving it in a production server, right? A server that is heavily used for production, especially, you want to make sure that if you are storing a large amount of data, you don't want to potentially cause any downtime in your servers. And because of that, sometimes instead of doing a full load, right, you can do an incremental load as well. And of course, if you're doing an incremental load, you need to make sure that you there's some sort of synchronization between your system as well as the final data store. Okay. So yeah, so that is the entire ETL process that typically as a data engineer you would be heavily involved in. So now we'll just go through some of the tools that that are available in the market. So these are some of the, just for you to know, these are just some of the common players that we have when, for example, we're looking at ingestion. Okay, so sometimes we like to use this Stitch or Matillion tool to help us ingest our data. But of course, sometimes if you're just doing a very simple API call, or if you're doing an FTP, of course, you can just have a Python script that would be constantly pulling from your API or pulling from your from the other servers that you need to connect to get your data. Okay, and then of course the next thing that you want to do if you have a data warehouse. So if you notice, this process takes in an ELT process. Okay, so you're extracting and then you are loading into a data warehouse before you do your transformation. Okay, and of course you can do your analytics at the end. So if you're looking at data warehouses, right? So these are some of the common players for data warehouses. You have things like Snowflake, Google's BigQuery, Amazon Redshift, or Microsoft Azure Synapse Analytics. These are some common data warehousing solutions you can look into. And then, of course, we have our transformation tool. So again, these are some, if you want to do your transformation, you can make use of dbt, lookml, Matillion. Of course, again, if you want, you can use Python, right, to build your entire transformation script. And then you can just store it in your server and then call it and run it on your data as and when you need. Okay. And then finally, some of the analytics or the BI, business intelligence tools you can look at. So if you're looking at visualization, you can consider like Tableau, Click, Kibana. These are just some of your tools. Okay. So I'll just go through the data integration trends quickly, and then after that we'll move on to our hands-on approach. Okay. So what are some of the trends, up and coming trends that have been happening recently? Okay, so previously, right, we've always been looking at when you're looking at ETL, you can actually either store your data on-prem. On-premise meaning you have your servers and your company is the one that is actually taking care of the servers. Okay, so your company has like an infrastructure team that's actually ensuring that the servers are always up and running. Okay, so that is on-premise. Another concept that we have is cloud. So a cloud kind of solution is whereby all your servers are on the cloud. And for example, AWS, Amazon, they are the ones that, if you have heard of like AWS Cloud or Google Cloud, GCP, right? Amazon and Google respectively, they are the ones that are taking care of the servers and making sure that it's always available. So as the end user, when you actually use their servers, right, you don't have to be so concerned about whether or not your servers are up and running. Okay, so that's on-premise and cloud. So sometimes in your ETL process, right, you can store your data on-prem in your own servers or on cloud. Okay, but recently there have been a shift towards, especially when organizations are trying to move from on-prem to cloud, right, there have been some sort of hybrid integration platform, meaning there is a hybrid on-prem and cloud kind of solution whereby while they are still using their on-premise solution, right, they're trying to shift towards cloud. So there is like a hybrid kind of like on-prem and cloud solution at that kind of time, at that kind of period. So whenever you're doing this, right, you want to ensure that you are able to talk from your on-premise. You want your on-prem servers to be able to talk to your cloud processes as well. There should still be some sort of connection so that your data is still seamlessly being kind of like transferred, rather than like it's like very jarring. Your on-prem data and your cloud data are very different. Okay, so you need to take into account of that shift. So typically when we have some sort of hybrid integration platform, what are some things that you want to make sure you have, right, is basically you want to make sure that you have your API lifecycle management. So your APIs are all managed properly and that your on-prem servers are able to talk to your cloud servers and vice versa, so that data is able to go seamlessly from one to another. You have good data integration, so it's able to transfer from one to another. And it's very messaging and event-driven architecture, meaning that if at any point, for example, if data has been successfully transferred to your cloud, or if there's new data that is coming in, you want the two systems to be able to talk to each other. And of course, you want to ensure that there is potentially high speed of data transfer, because if there is going to be a very slow transfer rate, right, between your cloud and your on-prem and your cloud infrastructure, right, it's going to cause your entire data pipeline to be slowed down, and it's going to cause a lot of problems for people downstream. Okay. And of course, you also want to ensure sometimes as we are moving towards big data, right, you want to have like real-time integration rather than batch processing. Because previously, right, a lot of times whenever we do any data analysis, it has always been very batch oriented. So meaning, right, you just take all your data at one shot, maybe every every Monday morning, and then you run a weekly report on what happened on the last week on your data, and then after that you send this report to the C-suite managers. So it's very like batch oriented. It's very like weekly basis what happened. Of course, that may be important for some companies, but of course, as we move towards like real time kind of integration, real time where your data is coming in real time, you want to also be able to analyze your data in real time. And again, this is also going in, sorry. This also goes back to like big data, where your data is coming in at a higher speed. So that's why you need to be able to analyze your data at as it comes in as well. So again, if you're thinking about real-time analysis, streaming analytics, you can consider like Hadoop and Spark. Okay. So yeah. Finally, when so traditionally, right, we've always been doing ETL, right? Extract, transform, load. When big data came in, we moved towards ELT, whereby we extract and load the data and then we transform it on the fly. So there is something else called EL bracket T, whereby you kind of decouple the transformation from your extraction and loading. So it's kind of related to also data governance, whereby you want to make sure that whoever has access to basically it's ensuring that you want to make sure the right people have the right access to the right data. Okay, because sometimes when you do ELT, you transform all your data at once, and then your end users has access to all of it, right? But there may be times when your data scientists may not necessarily need certain data that your data visualization analyst may need, so that they can visualize certain metrics on your dashboards for the for the C-suite, right? But this data may not be necessary or may be too sensitive to put inside your data science model, for example. So because of that, right, we are also slowly moving towards a EL bracket T kind of format, whereby this takes into account data governance and that only the right people have the right access to transformed data. Okay, so yeah, these are some of the trends that we have in the data integration industry. So we are going to move on to our hands-on session now. So let me just share the link so that y'all can access the Jupyter Notebook. Okay. Let me just here. I'll share it in the Q&A again. I'll share it in Q&A. Okay, so maybe while giving you all some time to go and download the the resources, I can answer some questions as well.
Okay, sure. Yeah, so
Stop sharing.
let's start about the Q&A. We can choose few, but I think we can answer all so far. Right.
Okay,
the
sure.
first, right. So far, the first one is from Fernando. What are the skills required for data engineer? What courses should one finish? Or master or doctorate or take mentor certification? Thank you.
Okay, so yeah, that's actually a very valid question. A lot of people always ask this question. So what are the skills required, right? So typically, as I mentioned, the goal of a data engineer really is to develop a data pipeline. So in developing the data pipeline, like, what it entails is really good communication skills with your end users. So soft skills, communication skills is definitely one. And the other thing is to develop your ETL, your data pipeline. So it depends. It always depends. So programming skills would definitely be something that is important. So I would probably suggest maybe Python or Java as a language to learn. And then you can focus it towards, there are courses out there available that allow you to focus your programming skills towards a certain industry or certain role. For example, you can learn Python for data engineering. There is also Python for data science, because depending on what role you want to focus on, the kind of concepts that you need to learn and program are quite different as well. So yeah, Python, Java, these are some very important languages that I would recommend. And then what course should you do, master's or doctorate? So in the IT industry, right, actually, I don't think masters and PhD. I mean, having a masters and PhD definitely says something about you. Definitely says that hey, you are certified. You've done 2 years. You've done a 2-year masters in AI, or you've done a PhD in AI. But if you're looking at data engineering, right, something that a lot of companies, organizations look at is actually vendor certification, as you mentioned. So AWS certification, GCP, Google Cloud certification. Um, what was the other one? Typically, having cloud certification would give you an edge, a competitive edge against others. Um, yeah, and of course, if you know that the certain company that you are applying to, right, they're looking at maybe X plenty, a certain ETL tool, you can also be certified in that area. And of course, like Tableau certification, Click certification, there's also all those kind of certification you can consider. Yeah, so I would definitely recommend certifications because it's faster than doing a master's and a doctorate, and it also sets you apart.
Hmm.
Yeah.
All right. Thank you. Understand now. So the next one is Ryan Pramana. Hi, Shamin. I want to ask, is data prep processing like stop word removal, hashtag removal in tweet part of the job of the data engineer?
Okay, yeah, hey, Ryan, definitely good question. So, when you're talking about like stop word removal, hashtag removal, and tweets, right? These are more towards NLP, the natural language processing domain, where you're focusing on text data rather than structured data. So it can be part of the job of a data engineer. So it's again how the data engineer works with the data scientist. So the data scientist can tell you, hey, for all my text data, right, I want to make sure I remove stop words. I want to remove all this punctuation. I want to do all the part of speech tagging maybe to add in whether or not this is a verb, a noun, a pronoun, etc. That kind of thing, right? So sometimes the data scientist may task the data engineer to do that. Or sometimes the data scientist may say also that, hey, I can do that by myself. I just need to ensure that I have the reviews or the tweets all in one column and then the user in another column. So that kind of thing. So it's really part of your kind of like your exploration process where you talk to your data scientists or your end users and they tell you what they want, what they need. But of course, it would be great if you have all these skills as well.
Hmm.
Yeah.
Okay. I see many questions coming in. So maybe do you want to continue your hands-on part first?
Okay, sure. Yeah, good
All
idea.
right. Yeah.
Yeah, okay. So I'll move on to the hands-on portion first and then we'll come back to the questions later.
Yeah.
Okay, I'll share my screen. Okay, can see my screen.
Yes.
Okay, thanks. So we'll go back to our notebook. So this notebook is a lot shorter than the previous one, so I think we should be able to finish this quite fast. But of course, again, I'll try to go slow for those of you who may not have used Jupyter Notebook before. Again, very quickly, right? If you need to open this notebook, just open Jupyter Notebook, okay? And then after that, it will give you a file directory. Then you just need to navigate to your folder, and you will find your IPY notebook there, your IPython notebook, and you'll be able to open it. So just click on it, and you'll open up. Okay, so let's just go through this quickly. So there's some notes here on what are the different Python libraries you can use for ETL. So, oh yeah, so just now with someone was asking, Shin was asking about like the stock data, right? So you can use this Y Finance API for stocks data. Okay, so it's a free API that you can use to query stocks data. So for abstraction, right, typically these are some of the libraries that you can use. So Beautiful Soup and Requests, right, these are typically you looking at HTML websites. So when you look at HTML websites, you want to try and extract data from your website, you will be able to use Beautiful Soup and Requests. Okay, so we won't be going through HTML code today, but if you're interested, there are a lot of resources on Beautiful Soup that you can look into and can teach you on how to actually extract data from websites. It's essentially kind of like web scraping lah. And you need to be careful when you do it because some websites actually say it's illegal. Like they will actually ban you from scraping your website. So if that's the case, I would highly encourage you not to scrape their websites. Okay. So that's for extraction. Then for transformation and load, right? Typically we can use these other few libraries. The one we'll be talking about today is PETL, P-E-T-L, here. ETL, Python ETL basically. Then of course there are other libraries that you can use, and some people also say they like to use pandas for ETL. So pandas I would say is more of a data analysis tool, but of course you can load your data into a pandas data frame and do any sort of transformation on it. Okay, yeah, so we'll be focusing on PETL today. And then, of course, these are some of the enterprise ETL tools that you can use. But for all these, right, typically you will need an enterprise license. So we'll just be focusing on Python today. Okay. So we'll be doing ETL with PETL. So these are all the different libraries that we will need to import. Okay. So OS and sys basically help you to get files within your directories. PETL is for ETL. Config parser, basically this is a good practice to have. Okay. Why? Because if you recall just now when we talked about ETL, we said that we like it typically to be automated, right? It's a script that just keeps running, right? So whenever we have that, right, we don't really want to touch our script. We don't want to we don't want to have the need to edit our script because that could lead to chances of error. For example, if I want to change the dates, right, in the in the file, right? Then I have to go into the file and I change it, and that could cause errors in other locations. I could accidentally add a full stop, a comma, and that could cause the whole script to not work. So that's why a good practice is to use a config parser, okay, whereby your script calls a config file and takes in all those values, and you just need to change the config file, so you don't have to touch the script at all. Okay. Request basically is to help us extract information from a website, a URL, okay, and then we have, and it's typically used for APIs. Datetime to get convert dates from string into a datetime format, okay. JSON, JSON is basically because when we have an API, right, as mentioned just now, our output will either be a JSON output or XML output. So we want to be able to interact with the output that we have, okay. And decimals because we have data types. Okay, so first let's talk about our API. Okay, so if you recall, API basically is to help us extract data from a certain source. So in this case, right, we will be extracting data from this website here. This Bank of Canada website basically let us use the API to query the current exchange rates. Okay, so you can go into this website if you want to find out more. But how the API works, right, basically is we will send a request to this website and we'll tell them what data we want, and you'll come back and tell us, give us the data. But when it comes back, right, it will also give us a HTTP code. Okay, and this API status code, and this API status code, right, will basically tell us whether or not our request was what the response is to our request. So typically, if you see a HTTP code 200, 200, or 201, 202, as long as you see it starting with a 2, it just means that it's a success, okay, and that it was accepted. If you see something like a 400 or 500, right, you will then know that there is an error in your code and the API did not return any result as expected. Okay, so if you see a 400 error, this means that potentially the error is on your side. So from your client server, from your client, there is some issue that is stopping you from reaching out to, from sending out that request to the server. Okay, so it could be many things. It could be maybe your code is wrong, or there could be a firewall that is blocking your request from going out. If you see a 500 error, 5xx error is basically a server error, meaning that the error is on the server side, it's on Bank of Canada side. So they will need to do something in order for us to be able to connect to them properly. Okay, so that's how you read all the different error codes. Okay, so you can go to this website here to find out more. They tell you exactly if it's 301, 302, 303, what does it mean? Because there's different implications based on the numbers. Okay. But in general, we like to see a 200. HTTP code, API code 200, because that is a success. Okay. So for file transfer protocol, you can actually refer to this tutorial here. It's a very short tutorial that actually shows you how to connect to a server. And you need to have another server set up for it to be able to send you files. So it shows you how to set up that connection between you and the server so that it's able to send you files. And of course, you can do it either FTP or SFTP. So you can either do it securely or just without the secureness. Okay. And next we move on to our config parser. Okay, so here, right, what we're doing is we're reading in a config file. So here you would have the config file here. Okay, so in this config file, right, you can see shucks, okay, never mind. Inside the config file, you can open it with a notepad on your desktop. You will be able to see that we have things like the start date and the URL inside the config file already. So this means, right, next time if I want to change the start date, right, rather than changing it inside my script, rather than putting it here in my script, I put it inside this config file. Okay, so that I don't have to touch my script at all. Okay, so it's a lot more cleaner and reduces the chances for error. So we just want to read in the config file here. Okay, that's what we're doing. And then the next thing that we're doing is we're getting the start date and the URL from the config file. So it just acts like a dictionary. So you just need to put in the keys, then you get the value. Okay. So the next thing that we're going to do here is we're going to call the API. So the API basically is referring to this Bank of Canada website. Okay, and we are making use of the request library, and then basically you just do a request.get and you put in your URL here. Okay, so if I just show you here, right, you can see the URL and you can see the start date. Okay, so you can see the URL here and you can see the start date here. So you're just putting in this entire URL and start date inside this function. Okay, and then it's going to get this URL, and the response will be inside this variable called response. Okay, and you notice here we print the response status code, which is a 200, which is great. So that just tells us that the Bank of Canada website responded, has successfully received our request and given us a response. So how do we see the response, right? So you can just look into this response. Okay, so if you first look into this response, right, it will just tell you that it's a response 200. So it's actually a JSON file, and in order to use it, to look into it, right, we need to load it into a JSON file, okay, and we need to load the text. Okay, so if you actually do response.text here, you will see that this is all your JSON of responses from the Bank of Canada. Okay, and of course there are other things you can get from response. So if you just do a response here, okay, so if you do things like a response dot, right, and you press a tab, in Jupyter Notebook they'll show you all the other parameters that you can get from this variable. Okay, so you can get for example, you can get the content, you can get the headers, the history, you can get the text, you can get the URL, you can get the status code, right? Status code be 200, etc., etc. You can get all these different information from your variable response. Okay, but what we want to do is we want to extract the response from we want to extract valuable data from this API response. So what we're going to do is we're going to load it into using JSON to load this text data, which is basically a JSON data. So just running this, right, you will then see that this is our raw JSON data, which we can interact with. So if you want to get, sorry, to go back a bit, the purpose of this ETL process is basically to get exchange rates from the Bank of Canada website to find out the exchange rate between USD and Canadian dollars. Okay. For different days, so it's on a daily basis here. Okay, so you can get that from your JSON file. Okay, so once you run this and then you go here, your JSON file will now show you that if you go look into observations here, Okay, because if you're looking at the key terms, right, you will then see you get like URL, which is not really what you want. What the data that you want all lies in here, right? All these date and the foreign exchange rate between USD and Canadian dollars, which was $1.29 for January 2nd. Okay, and then for 3rd January it was $1.29, 1.2988, etc., etc. So basically what you want is you want to extract all these data, right? So in order to do that, you need to call the observations key to give you all these values, which is what you do here. Okay, so from this JSON file, from this dictionary, when you call in observations, okay, it will then very nicely give you a list of dictionaries, and the dictionaries basically show you for every day what was the exchange rate. Okay, all nicely over here. So we have this exchange rate extracted out already, right? We've used the API to help us get the exchange rate from USD to Canadian dollars nicely into this list of dictionaries. The next thing that we want to do, right, is in this same folder, you will see that we have a Excel file, and in this Excel file, we have like all the different expenses in USD. So what we want to do is we want to convert this into Canadian dollars. Okay, so very simply, how we're going to do that is we're going to make use of petal. So first, right? Sorry, we need to put all these data, right? Because now it's in a list of dictionaries. What we want to do is we want to convert this into a list so that we can transform this into a data frame that we can then join later with this Excel spreadsheet. Okay, so our end goal, right, essentially is to get like Canadian dollars here, and then expense in Canadian dollars. Basically, this is what we want. Okay, this is our end goal. Okay, let me delete this first so that it doesn't screw with those of you who have not downloaded it. Okay, so so that's why we need to convert all these into lists. So very simply, right, what we can do is we can just look through this entire list of dictionaries. Okay, see, it's a list of dictionaries, right? And then we're just going to store the date and the exchange rate in these two lists. Okay, that's what we're doing here. And the next thing that we're going to do is we're going to convert this into a data frame so that we can join it with our Excel sheet that we have. Okay, so using Petal, okay, we can just create a data frame from columns. Okay, and then we just need to put in the list here, which we have created here, and then put in the header name here. Okay, once that is done, you will then see we have a data frame here very nicely that shows us the date as well as the exchange rate. Okay, and then we move on to loading in this Excel file. Okay, into Petal as well, Python ETL. So again, this is very simply just loading in your data from an Excel file into a Petal data frame, and you can think of it kind of like pandas data frame, because you can do things like dot head, and if you want a dot show or dot display, right, you can do a dot display to see your data here as such. Okay, so then you can also do other things like dot header to see your column names, because in pandas, if you recall, you just need to do expenses dot columns to get your column names. So in Petal, it's basically dot header. And you can also do value counts. Okay, so value counts, if you recall, pandas has an equivalent value count, right, to help you show the count of the unique values in a column. So same thing, Petal has a value count, but spelled a bit differently, so without the underscore. Okay, and then you can also do the value count of your column here. Okay. These are just some features that you have in Petal that I'm just showing you here. So you may not necessarily need to use all of them. Okay, but I'm just showing you what are the capabilities of Petal here. Okay. So another thing that you can do in Petal very nicely, right, is using dot display. You can actually highlight a certain column that you're interested in. Okay, so you can just define your highlight color here, and then you can do a dot display, and you can have a tiny caption here if you want. Yeah, okay. And then put in what you want to highlight, which row, which column you want to highlight. So in this case, I want to highlight the column USD. So I can just put in the style that I want is to highlight it a background color yellow. Okay, and then this virtual representation, this representation here is just saying that, so I just left this like tiny note here to say that the resulting string, so typically this is more for like debugging. So you notice here, I'm showing you that it's a date time format, right? So when you put this in, it actually shows you the format. What is the type, the data type. So this is a date time type. So you can see that here. Okay. And yeah, you can also do number of rows. So yeah, all these are just some of the cool features that you can use with Petal. Okay, so moving on, right? The next thing that we want to do is transform our data, right? So ETL, so transform. So how do we transform our data, right? These are just some of the functions that you can use to transform your data in Petal. But the key ones that we're going to be doing here today, the first thing that we want to do is join the two data frames, right? Because now we have two data frames. We have this expenses data frame that you saw here. And another data frame that we have is basically this exchange rate data frame, right? So for the date, what was the exchange rate? So we want to join these two data frames, right? So that's why we have our pseudocode here. We just want to join the data frames. Then we want to fill any missing data. So sometimes, right, there may be missing data in our exchange rate here. So you notice this is 2nd January, 3rd January, 6th January. So 4th, 5th January are missing. So for whatever reasons, the exchange rates were not there. So what are we going to do? Are we going to fill in a null value or what? So one way to do it, right, is you can actually downfill. So one method that we typically do in stocks data, right, is or exchange rate data, we like to downfill, meaning we take yesterday's exchange rate as today's exchange rate as well. Okay. Of course, there are different approaches you can take. You can also take average, you can take median, you can upfill as well. But this approach, we're going to do a downfill. Okay. And then after that, we'll remove any null values in the data, because we are not removing it first because we want to fill all the null values in the exchange rate first before we remove null values. Okay. And then we're going to calculate the Canadian dollars from the USD dollars by multiplying the exchange rate with the USD dollars. Okay, and that is basically what we're doing here very nicely. Okay, so first you notice we're doing an outer join. So we're joining both data frames, the exchange rate data frame and the expenses data frame, and we're joining it on the date column. Then we fill down the expenses with rate. Okay, so basically for the column rate, right, if there are any missing values, we take the previous day exchange rate and fill it down. And then we're removing all the null values. So anything that is null, we'll be removing. And finally, we are creating a new Canadian dollar column here, and we're doing a multiplication. Okay, so very nicely, right, you can see Petal allows us to do all these sorts of transformation. And then once this is done, right, you can save it to a CSV. Okay, or you can load it into a database, you can load it into a data warehouse, or you can save it into a JSON or whatever. Okay, so you can see very nicely, right, we can do ETL using Python as well. And once all this is stored in a script, right, you can just automate the entire process. Okay, so I'll let you all go back and read the rest of it, because the rest are pretty straightforward. It's basically looking at how you can do pandas as well and some of the good tips to take note of. Okay, so then I'll use the last 8 minutes for a quick Q&A session.
Sorry. Okay. All right. Thank you, Ms. Shumin. I hope you guys get all the knowledge. And now is the Q&A. Let's see what we have. Okay, George, how do we check on the duplicate data if the data sets are very large?
Okay, Josh. Okay, so that's a good question. So typically you would want to try and see, okay, if it's a huge data set, right? So one way is just to let your entire put it into like a Hadoop or a Spark and then just let it run. You just let the dot duplicates query run. Sometimes it'll just run for maybe like, I don't know, 20 minutes or something, and then you'll try and see if there are any duplicated data. Because another way, of course, is also to see if you have duplicates in terms of if you partition your data. So you can also do, if you think that there's going to be duplicates in the dates, right, then you can partition based on, for example, weeks or based on days, and then you can see if there are duplicates there. Or if you think something more key for you would be based on a specific column you have in mind, you can also just drill down. You can partition your data into, for example, education level. If it's tertiary education, primary education, basically break down your data into smaller data sets and then check for duplicates there. Because you will know that there should not be a cross of duplicates in the different categories, for example. Yeah, so that is one way to do it as well.
All right. All right. Thank you. And the next one is Alan Tan. Are there any recommended methods other than the MQTT protocol for extracting data logs from a low computing power computer to the data pipeline? And it is recommended not to run any extraction applications and software on it.
Wow, okay, very long question. Let me break down this question a bit. So, you're looking at other recommended methods besides the MQTT protocol for extracting data from low computing power to data pipeline. Okay, so for the suggestions that we had today, right? So like API and FTP file transfer protocol, right? These are just some ways that you can use to retrieve your data. There are of course other ways, other methods that you can use to extract your data. And of course, if you recall in our slides, we also mentioned what are some of the other extraction softwares, enterprise level extraction softwares that you can use to help you get your data. So there are definitely solutions out there that you can use besides just using like APIs and FTPs. And what are the pros and cons of that, right? So when you are using all these enterprise solutions, they will probably sell themselves as more secure, more seamless, faster. They may even do some of the basic cleaning for you. Okay, but of course, when you're using all these enterprise solutions, the downside sometimes is that you're locked into their features. So whatever features, there may be certain special use cases or edge cases that you may want to include or exclude, which an enterprise solution may not necessarily allow for if they don't allow you to go down to the code level and change it. So because of that, you will have to see whether or not you want the flexibility in terms of code where you can really go down and change it, or whether you are okay to be using an enterprise solution where usually they'll brand themselves as more secure, faster, or whatever in terms of extracting your data. So you need to weigh the pros and cons. Yeah.
All right. Thank you. So the next one we have Yo Kencho. Why ELT doesn't store the data somewhere?
Okay. So why ELT doesn't store the data somewhere? I'm not really getting your question because ELT, right? Basically, what happens is extract, load, transform, right? You are taking the data. For example, if you go to like Hadoop, okay, Hadoop like big data, Hadoop and Spark, right? You're actually taking the data from Hadoop and Spark, and then you're transforming the data. Spark is helping you transform the data, and then it would finally load the data. It will store the data somewhere. It will either store it back in Hadoop for the next person to use, or it could output it as a smaller I'll put it into a smaller database because maybe your final transform data is much smaller and it can be stored in a database, a data warehouse that your analytics team can then take and use. So at the end of the day, right, what ELT does is extract load is because it extracts data from whatever system, load it into, for example, extract it from all your different sources and then load it into a staging environment. For example, in Spark, you will load your data into a RDD, transform your data, and then it will still ultimately store your data somewhere or load it somewhere. So there is still like a storing process at the end of it. It's just that you kind of transform your data based on when you need it to, not necessarily like, because how should I put this? Not everyone may necessarily need your transform data. Okay, so you don't transform your data as it comes in. You transform your data when you need it. Yeah, I hope that answers your question.
Okay, thank you. So the next question is from Alan too. He
Okay.
say, he asked, for a big data pipeline, is it better to store the raw data before going through the transformation process?
Okay, good question. So, is it better to store the raw data? Um, yeah, so typically, right, what happens is that the data comes in, it gets stored in HDFS for Hadoop, let's say, it gets stored in Hadoop, and then after that, at the same time, right, Spark is also pulling from Hadoop. So the data is already stored in Hadoop, but Spark is querying this data to do the processing, do the transformation. So it's actually already stored in your HDFS system. And then the transform data will also be stored somewhere else or used for whatever reasons. Yeah, I hope that answers your question.
Okay, so because we are running out of time, so I will choose one last questions. Okay,
True.
so Victor Wong. Hi, Shumin, can you please show an actual work snapshot from start to end as an example how big data is being applied to real world project or as a part of your work? Is it?
Okay.
Or
Okay. An example of how big data is applied to real world project or part of my work. Okay, I can kind of share like what I did last time in terms of my big data project. It was a very um, I can't give too much details because it was a bit sensitive, but I can just
yeah.
tell you like how it works like generally. So generally, right, whenever you have a big data project, right, what happens is that it will take in your data. Your data will come from somewhere. Typically, it's like streaming in, and if you're talking about big data, right, it could be like kind of like 10 gig per minute kind of data coming in, and you need to store all these data in like Hadoop or whatever storage system you decide to store your big data in. For me, it was Hadoop lah. So we stored it in Hadoop, okay. And then after that, what we did was we actually kind of had a more batch-oriented processing, but batch-oriented, our batch time, right, was actually set at every 15 minutes. So meaning, right, instead of processing the data as it came in, we kind of aggregate the data into 15-minute chunks, and then we and then we transform all these 15-minute data. So data comes into HDFS, Hadoop, then Spark comes in, takes 15 minutes of data, 4 o'clock, okay, let's say 4:30. It will take 4:15 to 4:30 data, transform it, save it. And then after that, um, 4:45 it will run again, and it will take like 4:30 to 4:45 data, transform it, save it. And then at the other end, right, we have a data visualization solution. So we were using ELK lah. So ELK, we have Kibana. So Kibana would then actually take all these data and then visualize it into a dashboard. And then that dashboard will be consumed. So you would see the dashboard being updated every 15 minutes based on data that comes in. So that was kind of like how our big data project kind of worked. Yeah, but I can't talk too much about the use case. I'm sorry. But there are definitely a lot of use cases online that you can read as well. But yeah, I hope that kind of answers your question.
All right, thank you. So that will be the last questions for today. And one more time, I would like to say thank you to Shumin and Smartcademy for today's very great workshop. And before I end this session, I would like to do a short reminder to every participants that we actually have collaborated with Alibaba Cloud, and they are helping their hackathon. Please go to our website abcde.asia and go to join. Click the join challenge to take part of the hackathon. The prize pool is up to 30K US dollar. Please do not miss the chance. All right. So I think that's it for today, and the ABCD event is end now, and we will be back next year. And I hope the time the pandemic is get over, and we will be meeting you guys on the venue, and we will do hackathon again together. Thank you so much, and thank you, Miss Shumin. Bye
Thank
bye,
you. Thank you,
everybody.
everybody. Bye bye. Stay
Bye
safe.
bye.